All right, so now that we know a little bit about empirical formulas, we're going to see how we can take that and turn it into the molecular formula, which is the formula for the actual number of atoms we have in a particular compound. So as a reminder, the empirical formula is just the smallest or the simplest whole number ratio of the atoms in a compound, whereas the molecular formula represents the actual number of atoms in a compound. So in order to get to the molecular formula, what we're going to have to do is take our empirical formula and multiply it by some whole number, some small whole number. And specifically, what we're multiplying here are the subscripts from the empirical formula by some small integer, right? That integer could be 2, it could be 3, 4, 5, etc. So we can go back and forth between the molecular formula and the empirical formula by using that small integer. And our goal today is going to be how to determine that small integer and be able to determine our molecular formula. So let's recap really quickly. If we have a simple smallest whole number ratio or an empirical formula for a compound made up of carbon, hydrogen, and oxygen, such as CH2O, right? There's no smaller whole number ratio you can get for that compound. That empirical formula can actually represent several different substances, right? So for example, CH2O is the empirical formula for acetaldehyde, but it's also the actual molecular formula for acetaldehyde. Something like lactic acid, right, has the molecular formula C3H6O3, and if you divide all those subscripts by 3, you end up with the same empirical formula. As you should realize, acetaldehyde and lactic acid, right, these are not the same. These are different compounds, even though they have the same empirical formula. So we're going to be looking at how we can determine the molecular formula if we start with the empirical formula for a compound. So what we're going to have to do, all right, is we are going to determine that small integer that we're going to multiply the subscripts of the empirical formula by. So for example, if we have our empirical formula like this, CH2O, if I multiply those subscripts by some small integer, let's say we multiply the subscripts by 2, all right, so remember when you don't see a subscript, 1 is understood to be there. So if we multiply each of those by 2, right, then we end up with C2H4O2, and that is the molecular formula for acetic acid, which is just vinegar. So this 2 here that we're multiplying those subscripts by, that is our small integer. And that's really the central part of getting from your empirical formula to the molecular formula. So how are we going to get that small integer? Well, it's actually really simple. That small integer we get by dividing the molar mass for the compound, which we know how to do. We've seen it in the previous sections. We're going to divide that by the formula mass for the empirical formula. All right, so the molar mass for the compound, which is usually going to be given to you, we're going to divide that by the empirical formula mass, which if we have the empirical formula, we can calculate that. All right, so let's take a look at an example. So let's take a look at this one here. So it says, given the empirical formula for ascorbic acid, so C3H4O3, that's the empirical formula. and the molar mass of its molecular formula, right? So the molecular formula mass is 176.12 grams per mole. We can now determine what the molecular formula is, right? So let's write that information down. We have our empirical formula as C3H4O3 and we're also told that the molecular mass or the molar mass for the molecular formula, let me rewrite that, the molar mass for the molecular formula is given to you as 176.12 grams per mole. Okay, so we're given one piece of the information that we need. Now, with the empirical formula, what we can do is take that empirical formula and determine its molar mass. Okay, and we can do that. We should be good at doing that at this point. We just multiply the individual molar masses for the elements. We add them together. So we have 3 carbons plus 4 hydrogens plus 3 oxygens. All right, so 3 times 12 plus 4 times 1 plus 3 times 16. And that's going to give us 88.06 grams per mole. All right, so that is our empirical mass. And we were told that the molecular mass, the molar mass for the molecular formula, is 176.12. So to get our small integer then, all we have to do is to divide those two. So our small integer is the molecular mass, which is this, divided by the empirical mass, which is this one. All right, so we just substitute those, 176.12 by 88.06 grams per mole. Grams per mole go away, and if you divide those two, you'll see that it ends up being 2 as your small integer. So what are we going to do with that? Well, we're going to take our empirical formula up here, which we were given. So we're going to multiply the subscripts of the empirical formula by that small integer that we just calculated, which was 2. All right, so we have C3H4O3, and we're going to multiply those subscripts by 2. So 3 times 2, 4 times 2, 3 times 2. So that's going to give us C6H8O6, and that is your molecular formula. Okay, and this represents the actual number of atoms in this compound, which was ascorbic acid or just simply vitamin C. Okay, so in order to determine the molecular formula, we first of all need the empirical formula. the smallest whole number ratio. From that, we can determine the empirical mass. We can then take the molecular formula mass, divide that by the empirical mass to give us our small integer or small whole number. And we're going to take that small integer and just simply multiply it by the subscripts of the empirical formula to give us the molecular formula for our compound.